this is Dr. Fitzgerald. In this video, we want to discuss rules of rational exponents, so their properties, and how to simplify expressions that have rational exponents. So let's start with this quick little definition or property. If I have a to the 1 over n power, that can be written simply as the nth root of a. So once again, a to the 1 over n power can be written as the nth root of a. Likewise, if I have a to the m over n power, this can be written as the nth root of a raised to the mth power. Also, this is the same as saying the nth root of a raised to the nth power. So notice I can raise my a to the n power directly under the radical, or I can raise the whole quantity to the nth power outside the radical. These two statements are equivalent. They're equivalent there. So what I like to say is, how do I really remember which one's my power and which one is my root? That is, which one is raised to the power and which one do I take the root of? So I'm going to write it down here. If I have b to the m over n power, I like to think of it as b to the, my numerator is power, so I like to think power over root. So when I have that rational exponent, the numerator represents the power and the denominator represents or denotes the root. And how do I keep that in mind? I like to think about, when I think of tree roots or any kind of root, where do roots grow? Roots grow from the bottom, so that bottom number denotes your root. So that's a silly thing, but it helps you remember which one's your power and which one's your root. Your root grows from the bottom, so the bottom number represents our root. So now let's look at a couple of examples here. What if I needed to write this in exponential form? So I'm going to write here, I want to write in exponential form. So I want to take the radical form of the square root of 3, and I want to put that in exponential form. Well, remember, guys, if there is no number written, that this index here really is a 2, that index really is a 2. So how can I rewrite this? This really becomes 3 to the, remember, my root, the number that represents the root, goes in the denominator. So that becomes 3 to the 1/2 power. So this is radical form, here's exponential form. Let's look at another example. If I have the square root of 3xy raised to the 5th power, 3xy raised to the 5th power here. So notice everything in that parentheses is being raised to the 5th power. So how do we deal with that in this situation? Well, once again, I'm going to take my 3xy, because they're all together in the parentheses. My power, remember the power is my numerator, so my power is 5. So the power is 5, and the root goes in the bottom. My root is 2. So that's 3xy raised to the 5/2 power. Remember, power over root. And so that's changing from exponential form, from radical, and putting it in exponential form. What if I have exponential form and I want to put that in radical notation? So what if I want to go backwards? And sometimes you will be asked to do that. So let's look at a couple of examples of changing from exponential form, right, from exponential to radical. So we want to go here from exponential form to radical. And the first example that we're going to look at is if I have 2x raised to the 3/2 power. Raised to the 3/2 power. So in this problem, I need to go from exponential form, because that's my exponent, and put this in radical form. So how do we go about that here? So once again, I know that I have 2x. My root. Which one's my root? Is it the 3 or the 2? But if you think about that silly concept, roots come from the bottom. So my root we see is 2. So that's the square root of that guy. And then all of that raised to the 3rd power. And that would be the final answer here. The only difference, somebody might have raised the whole entire thing to the 3rd problem, and we know that that's an equivalent statement as well. So let's look at one other term, or one other example. So in this particular case, what if I have b to the minus 3/2 power? And so once again, I want to put this exponential form and put it in radical form. However, I threw a little something different in there. We see that negative exponent. We have to remember for our properties of exponents, what does a negative exponent mean to do? So we're going to deal with that first. So let's rewrite and deal with the negative exponent. Well, in this case, we know that that simply means 1 over b to the positive 3/2 power. So we've dealt with the negative. Now let's deal with taking the exponential form and putting it in the radical form as asked. So we can easily do that now. That becomes 1 over, my root is 2, so I want the square root of b raised to the 3rd power. And that's our final answer in this particular example. Now let's look at how would I simplify expressions? So in these examples that we've looked at so far, all we've done was rewrite from exponential to radical form, or from radical form to exponential form, just rewriting. How do we simplify problems using that have our rational exponents? And remember, rational just means a fraction. So that really means that my exponent is a fraction. So just quickly remind yourself, if my exponent is a fraction, we know we should have a root. We know we should have a root. We need to rewrite this problem using some sort of roots if my exponent is a fraction. So now let's look at how do we simplify these expressions. So we want to simplify. So how do I simplify this? Okay, let's look at our first example that we want to show. What if I have 8 to the minus 4/3 power? 8 to the minus 4/3 power. So what's the first thing that we do when I have that negative exponent is deal with that negative exponent. So I want to rewrite this guy as 1 over 8. And when I change that, my exponent becomes positive. So it becomes to the positive 4/3 power. Now we want to rewrite this using radicals so that we can think of how to actually simplify this guy. So let's look at that. Now I have 1 over the cube root of 8, and I want to raise the power on the outside. Raised to the 4th power. And in that particular case, let's look at that. Well, now let's do the algebra on the inside of this. So what is the cubed root of 8? Cube root of 8. So that becomes 1 divided by the cube root of 8 is simply 2. And then we have to raise it still to the 4th power. So now this simplifies to just 1 over 2 to the 4th power. And what is 2 to the 4th power? Well, 2 to the 4th power is simply 16. So our final answer here is simply 1 over 16. Or 1 over 16. This problem simplifies simply to 1 over 16. Now let's look at another example. Let's look at one other example. In this example, I want to simplify 9 over 25, and I want to raise this guy to the minus 3/2 power. So once again, I have a negative exponent, but in this particular case, I'm starting out with a fraction. So how do I do that? 1 over a fraction. Well, if you recall, dealing with that, here, dealing with the negative exponent, it's just going to be the reciprocal of this part here. So this guy will simplify to 25 over 9. And that's dealing with our negative exponent. Now I have to the positive. I'm going to go ahead and write positive to make note that we pay attention that now becomes positive 3/2 power. So now I'm going to go ahead and use and write my radical notation. My radical notation then asks for, recall which one is going to be our root. Our root is at the bottom, the denominator. So we want the square root of these guys. So I want the square root of 25 over 9. And then I want to raise that guy to the 3rd power. Raise it to the 3rd power. Great. Couple more steps and we're almost done. The square root of 25 is simply 5. The square root of 9 is simply 3. And all of this raised to the 3rd power. One more step. Raise 5 to the 3rd power. We end up with 125. Raise 3 to the 3rd power. We end up with 27. So our final answer, 125 over 27. And so that's our last example of showing how to simplify problems that have rational expressions. Thank you.